All right, so today we're going to look a little bit at solving two-step equations. First, to get into how solving two-step equations, we have to identify exactly what does it mean to be a two-step equation. So you can see I already have here an example of a one-step equation and a two-step equation. With the one-step equation, we can see that we've got x plus 4 equals 13. Now the way we solve that equation is simply it takes one step. I would subtract 4 from both sides. Okay, this means I looked for the side with the variable, it was the left side. I looked at the operation, it was addition. I did the opposite of that, or the inverse operation, to isolate the variable. That leaves me with just an x, and that leaves me with a 9 as an answer. I've isolated the variable, x equals 9. A two-step equation is similar to this, except for there's two steps. There's two things to do. So if we look at our equation, we can see it is 3x plus 4 equals 13. We have two operations now. We have that plus 4, and we also have times 3. So now the thing that we have to think about with two-step equations is which operation do we undo first? Which one do we do the opposite of first? All right, so this right here would be some examples of some algebra tiles. Is visually showing what's going on here. If you used algebra tiles before, again, the long things represent x, the little filled in ones represent whole numbers, and we use these to sort of show and actually solve algebraic equations. So what I will do here, if I was solving this normally, what I would do is I would want to subtract 4 pieces from both sides, right? We always do the same thing to both sides of the equation, and that has isolated the variable and has left me with x equals 9, so we can see our answer. Now, if we wanted to look at the bottom part, or the two-step equation, we could see we have two options. We have two things we're going to have to do. If we want to get one x and isolate the variables, we both have to deal with that plus 4 and the fact that we have 3 of these things. So we're going to think about which one we would do first. Now, we can't divide the left side by 3 because, I mean, we could, but we'd end up with like a fraction of a little bit of a p. It doesn't really work. So instead, we would see that we would have to subtract the 4 first. 1, 2, 3, 4, 1, 2, 3, 4. Then we could split into 3 groups. And so I could split this into 3 groups, seeing that each x equals 3. Okay, so that can show us visually sort of why we're going to choose the correct operation to do. If we were to actually think about steps and put this into words, these right here would be the steps that I would use when I'm solving two-step equations. I'm going to first look for the side of the equation with the variable. For all of these, we're going to have the variable on one side. If you had the variable on two sides, you would have to do some work to make it so it's only on one side, but we're not going to go into that in this video. So what I'm going to do now is I'm going to look, I've got my variable on the left-hand side, and now I'm going to identify the operations. Step 2, identify the operations being done to the variable. We can see we are both adding 4 and multiplying by 3. Now, to solve, we're going to work in reverse order of operations, and we're going to do the opposite of the operations to both sides of the equation until you isolate the variable. So when we're looking at opposite order of operations also known as PEMDAS, where you would start with parentheses, exponents, multiplication, division, and you save the adding and subtracting for the end. When we're solving, since we're doing the opposite, we're going to start with the adding and the subtracting. So I'm going to do the opposite of adding 4. I'm going to subtract 4 from both sides of my equation. On the left side, that'll cancel out the 4's and leave me with 3x. And on the right-hand side, 13 minus 4 is going to give me 9. Bring down my equal sign. Now we see what we basically have is another one-step equation. All I have to do is to divide both sides by 3. Right? I looked for the left. There was an x. It was multiplied by 3. The opposite is dividing by 3. That'll cancel it out and isolate the variable. X is going to equal 3. Now, it's also always a good idea. Step 4 is to check your answer. Sometimes you'll be asked to do that. And to do that, I'm just going to take that and put it back in my equation and see what I get. So if I had 3 times x plus 4 equals 13, and I was to then replace the x with the 3 that I was trying, I would do my math. 3 times 3 is 9. 9 plus 4 gives me 13, which is what I wanted, right? You could go like that if you like. It brings it right down. It equals the same thing. So we know that that means for sure that 3 was the correct answer. We're going to look at a couple more quick examples. So let's say we had something like 2x minus 5 equals 11. If we're solving that following this process, we look for the side with the variable. It's the left side. We identify the operations being done. X is being multiplied by 2 and has 5 being subtracted from it. So I'm going to go reverse order of operations, which means subtraction first. I'm going to do the opposite of subtracting 5. I'm going to do it to both sides of my equation. That'll cancel out the 5s and leave me with just 2x. And 11 plus 5 will give me 16. Now I look, I've still got one operation left. That's multiplying by 2. So the opposite of multiplying by 2 is dividing by 2. Divide both sides by 2. That'll cancel out the x's, or the 2. Isolate our variable. And we get x equals 8 as an answer. Again, we would want to think about putting it back in the equation to check. In this case, that would be 2 times 8 minus 5. 2 times 8 is 16. 16 minus 5 gives me 11, which is what I wanted in the first place. Let's do another example right here. Let's say you had something like 14 equals 2x plus 7. Now this time you can see the variables on the right hand side, but it really doesn't change the problem. It's going to be very similar to that last one. Two operations, multiplying by 2 and adding 7. The opposite of multiplying by or adding 7 is subtracting 7. Do that to both sides. That gives me 7 equals 2x. Then I would have to divide by 2. Divide this side by 2. Divide that side by 2. That isolates the variable and gives me x on that. And 7 divided by 2. I could do my long division with my decimal. And I would get 3.5 as an answer. Again, ideally, we're going to stop and think about checking. In the interest of time, I'm just going to keep going with one more example. Let's do it right here. Let's say you had something like x over 5 plus 4 equals 19. So for solving this, what we're going to do is we want to do the opposite. We've got divided by 5. That's what that fraction bar means. And we've got adding 4. So we go reverse order of operations. We're going to have to subtract 4 first from both sides. Remember, it's doing from both sides of the equal sign. When I subtract on the left-hand side, that cancels out the 4, leaves me with x over 5, or x divided by 5. And I get 15 on the right-hand side. Then I'm going to have to do the opposite of both operations. On the left-hand side, it's divided by 5. The opposite of that is going to be times 5. So both sides are going to have to be times 5. That'll cancel out that and isolate our variable. 15 times 5 would give me 75. And then that would mean my x is my answer. Again, you want to put that back in the equation and check it. So if I put 75, if I did it right here, I could do 75 over 5 plus 4. 75 divided by 5 is 15. 15 plus 4, again, gives me 19, which is what I wanted in the first place. So that would mean my answer is x equals 75. So again, the key to two-step equations, look at the operations. You're going to do the opposite of them, but always start in reverse order of operations. So start by doing the opposite of the adding or the subtracting. Good luck.